Good afternoon. We are wrapping up our Unit 11 this week. So that means we will be testing next week. So wrapping it up this week, testing next week. This is our last unit. So that means that last week of school is our last time to do retakes. So if we get any wrong on this test next week, then we have to do retakes that last week of school. You don't want to have to do retakes the last week of school. Make sure you get 100% on the test. Okay? These are all COs for this test. So if you don't pass one, it's not like you're not going to pass pre-algebra. Okay? But we do want to make sure we have a good grade. We do want to make sure that we have a good understanding of the material. So let's look at CO67. I can classify and draw regular, convex, and concave polygons. So first thing we need to know is what is a polygon? A polygon is a geometric figure made up of 3 or more line segments that intersect only at their endpoints. So, what would be an example of a polygon? Polygon could be, that could be a polygon. So, any shape that has straight line segments that only connect at their endpoints. So somebody said a square. Yeah, a square is a polygon.
A rectangle.
Rectangle is a polygon. Not a polygon might look like this. Why is that not a polygon? It's intersecting in the middle, not at their endpoints. Here's another example of not a polygon. Why is that not a polygon? It doesn't have a straight line here. It must be a line segment. In order to be a polygon, it must be a line segment. So, if we have a curve, not a line segment, okay? What about?
No, they don't connect. No.
Katie, why do you think it's a polygon? Oh, you said yes. Well, you said yes, but you must have been meaning yes, it's not a polygon. Okay. Maddie, why is it not a polygon?
Because they aren't they all connecting at their ends?
They're supposed to connect at their endpoints. It is not connecting. So it's not a polygon because it doesn't connect. So let's look at our names of our polygons. If our polygon has 3 sides, what name do we call it?
Triangle.
4 sides.
Square. Rhombus.
I am not looking for a specialty 4-sided figure. What do we call any 4-sided figure? A quadrilateral. Quad means 4. Lateral means side. So quadrilateral. That's a long one. So a square is a quadrilateral. A rectangle is a quadrilateral. A rhombus is a quadrilateral. A trapezoid is a quadrilateral. They're all specialty types of quadrilateral. What we're working with on this objective is just the general 4-sided figure. Any 4-sided figure is a quadrilateral. What if it has 5 sides? Penta means 5, pentagon. What about 6?
Hexagon.
Hexagon. 7. So I have seen it both ways. Heptagon, and I have seen septagon. So you should know both. Hepta and septa both mean 7. I've truly seen it both ways. What about 8? Octagon. 9? Nonagon. And 10?
Decagon.
Decagon.
I said that was first, Paul. Yeah.
Oh, did we get a gold star for being first?
Yes.
No.
What if you get a gold star?
Okay, so we know what a polygon is. Finn?
I know on both sides of this.
What?
Dodecagon.
Okay. All right, so for our objective, we just have to go up to 10, but it's always good to know higher. Regular polygon. A regular polygon, different than just a polygon. So a regular polygon is a polygon with all sides equal in length and all angles equal in measure. So if we're going to talk about a regular quadrilateral, what would that be?
Square.
Square. What about a regular triangle?
I think that would. Sure. It would work because it's the same angle.
What would we call it?
Equilateral.
Not isosceles triangle.
Equilateral.
An equilateral triangle. We're going to talk about those, I think, actually tomorrow. Okay. How are we feeling about polygons and regular polygons? Okay. I'm going to erase and move it up. Now, when we are looking at our polygons, congruent sides, what does congruent mean? Equal. So they're the same. Congruent sides, equal side lengths are marked with notches through each side. So if I were to draw that isosceles triangle, these two sides are congruent. So they would each have that one notch. If we were to have a rectangle, we have this side is congruent with this side, but I've already done the one notch. So now I need to do two notches to show that those two are also congruent. So you just want to match up how many notches are on it to which one is equal with. Congruent angles are marked with arcs through each angle. So let's say this angle and this angle are congruent. I've seen it like that with a notch on the angle measure, or it could just be, if it's this angle and this angle, it would just show that those two are congruent. So it's the ones that are marked the same are the same measure. Congruent makes sense? Okay, now, how many of us have heard of concave and convex polygons? Ooh, you did in 4th grade?
Yeah, I don't know.
So that was a couple years ago. So this is a good refresher for us. Sam, what do you think a concave polygon would be? So concave means it's caving in. Let's look at the technical definition. A concave polygon will always have at least That's really messy. Oh my.
Oh, dang. There we go.
Oh, my finger just tapped it. Have hats. Not what's readable. At least one reflex interior angle. So what that means is the angle measure is greater than 180 degrees. So the interior angle is greater than 180 degrees. So what Sam said was that it's caving in. So if we are caving in like that, it caves down. If we look at our interior angle measures, to go from here all the way to there, that is an angle measurement. It's bigger than a straight line. It's greater than 180 degrees. So it's going to look like it's caving in at one part, and where it caves in is greater than 180 degree angle. Colin.
What if it's just like an obtuse triangle?
So an obtuse triangle.
Oh, greater than 180.
Yeah, that's still less than 180 degrees. So it has to be greater than 180. That was a good question. Any other questions about concave polygons? All right, so if concave means it's caved down, convex has interior angle measures or interior angles are less than 180 degrees. So if we draw a pentagon, each of the interior angles is less than 180 degrees. So that obtuse triangle that Colin was just asking about, each of our interior angles is less than 180. Not adding them together, just looking at each individual angle, it will be less than 180 degrees. Then we know it is convex. So concave has an angle that's bigger than 180, where it caved in. Convex, they're all less than 180 degrees. How do we feel about that? Leah?
Could be like two angles, there'd be like a concave and convex angle in the same shape.
We're not talking angles when we talk concave and convex. We're talking the polygon. So we have less than 180 and greater than 180. Because we have that greater than 180, it is a concave polygon. So you can't be a concave and convex polygon at the same time because we're looking at all of the angles. So it's either going to be one or the other. Okay, so we're gonna have some smaller angles, but it's still concave because one of them is too big. That was a good question. Any other questions? Okay, so on our work page, we need to, let's scroll up and see what we're doing. We need to classify our polygons as regular. What does it mean if they're regular?
All sides are equal.
All sides, all angles are equal. Convex, all the angles on the inside are less than 180 degrees. Concave means there's at least one angle that's bigger than 180 degrees on the inside. And then by its number of sides. So you're going to tell me, is it regular, convex, concave? And then tell me what we call our figure. Is it a quadrilateral? Is it octagon? So think about what number of sides it is, what that measurement is. So you're going to have 2 words for each shape. Then you're going to draw an example of what one of these polygons would look like. So a nonagon, that's an easy one. Okay, think about how many sides a nonagon has. Draw a shape. It has that many sides. Does it have to be all equal sides? All equal angles? No. You just need to make sure you have that specific number of sides. If it's regular, what does it mean? If it's concave, what's it going to look like? So really think about what your shapes will look like. Then you're going to write whether each statement is true or false. And if it's false, you're going to draw or write a counter example. Make it true. And this unit has quite a few new terms. Time for some review. So you're going to review what we talked about last week. Adjacent angles that are complementary, a linear pair, supplementary angles, a figure that is not a polygon. So it's just a quick little touch point review. Make sure you remember what we did last week. Any questions on today's assignment? Chase. Heptagon is 7 sides. Septagon and heptagon, they're both different names for a 7-sided figure. Leah.
There's a shape of 12 sides.
Yeah, one of them is 12 sides.
Where?
The red cross.
Yeah, it's 12 sides.
Well, why would Mr. Schultz do that? So, let me get the correct spelling for us. So since his examples went up to 12, let's do 11, just so we know it. So an 11-sided figure would be called a, hen decagon. Yeah. 11-sided figure is a hen decagon. And a 12-sided dodecagon is spelled this way. We want to make sure we're spelling it correctly. D-O-decagon. So dodecagon.
Oh. Yeah.
So because his examples went up to 12, we have to make sure we write up to 12 so we know it. So on your help sheet, you're going to want to make sure you write them up to 12 on the help sheet for the test next week. Okay. Any other questions or things that you noticed on his work? All right. So with that, we're going to say goodbye to our friends at home. We hope you are well and hope to see you soon.